Offshore wind energy is one of the fastest growing sectors in renewable energy. But what makes this possible? Floating Wind Turbine Installation Vessels, or WTIVs. Unlike their predecessors, these turbines are buoyant. As the world races to transition to cleaner energy, floating wind farms are emerging as the next frontier in the renewable energy revolution. So let's dive into these remarkable machines that are powering the green energy revolution. First, let's understand what floating wind turbines are. Traditional offshore turbines are anchored directly to the seabed, while floating wind turbines rest on floating platforms. This allows them to operate in much deeper waters. The demand for renewable energy is increasing, and so does the need to tap into the vast potential of offshore wind energy. Typically, traditional fixed-bottom turbines are limited to no deeper than 60 meters. Beyond this, these turbines are unworkable. Unlocking the deeper oceans, where wind speeds are higher and more consistent, depends mostly on floating wind turbines. This changes the course of renewable energy's destiny. Now, you may be wondering, what is a floating wind turbine installation vessel, or WTIV? Well, the function of the WTIV is: imagine a giant ship that doesn't just sail the seas, it brings the future of renewable energy with it. WTIV is a specialized offshore marvel designed for transporting, lifting, and installing the massive components of floating wind turbines. Think towering turbine towers, the power nacelles, enormous blades, and the floating platforms that keep it all afloat. You see, traditional fixed-bottom turbines can only operate in shallow areas, but WTIVs are like floating construction sites. They travel to installation locations carrying the turbine components safely across open waters. Then, they deploy their advanced lifting systems, positioning each turbine component with pinpoint accuracy on the floating platforms. These vessels ensure that every piece is securely fastened, ready to operate in the harshest conditions far out at sea. WTIVs are designed to withstand the heavy-duty tasks of offshore wind turbine installation. They can carry and transport the massive turbine components. Some of these components can weigh several hundred tons. These vessels are also capable of carrying multiple turbines at once. This makes them a pivotal part of large-scale offshore wind farms. One of the most remarkable features of WTIVs is their dynamic positioning, or DP system, a combination of thrusters and GPS to keep it steady in one precise location during the installation process, even in the face of wind, waves, and currents. WTIVs are equipped with powerful cranes and lifting systems. They allow them to hoist the heavy components of wind turbines. Some WTIVs use dual-lift cranes. This allows for even more efficiency and stability when installing the various components of a floating wind turbine. The combination of ballast, active stabilization, and advanced design makes the WTIV capable of operating safely even in some of the roughest conditions on Earth. WTIV's crane and winch are controlled by hydraulic pumps and actuators. This ensures smooth and precise movements under heavy loads. Traditional anchoring techniques rely on heavy chains and anchors to secure the vessel to the seabed, but dynamic positioning, or DP systems, use thrusters and GPS. They keep the vessel locked in place with pinpoint accuracy. The flexibility of DP allows the WTIV to work in deeper waters even where anchoring isn't feasible. However, managing this system has its challenges. Thrusters must work continuously to counteract wind, waves, and currents. This requires advanced real-time monitoring and control systems. So, how does this all work? First, the pre-installation preparations. It involves loading the turbine components. Then, these components are carefully secured on the vessel's deck using advanced crane systems. Now, each piece is in place and ready for transport. Then, there's a thorough system check. Everything from power management systems to the DP system is operating smoothly. Next, the team tests all onboard systems: the cranes, stabilizers, hydraulics, everything. Next, the installation site is also prepared. For this, survey teams perform site assessments. Environmental data like sea state, wind conditions, and tidal patterns are collected to determine the best timing and approach for installation. Once the pre-installation steps are complete, the WTIV sets off to the installation site. As it arrives at the designated site, the crane lifts the turbine components from the vessel's deck. Now the installation process begins. The first component to be installed is usually the tower, then the nacelle, the power generation unit, and finally the blades. The crane precisely places each component on the floating platform. During this, the DP system continuously monitors and adjusts the vessel's positions. Now that the installation is done, the securing process begins. The turbine is fastened to the platform with specialized mooring systems. Electrical engineers connect the turbine to the platform's power transmission systems, which establishes the necessary electrical connections to bring the turbine online. After this, the team conducts final checks to ensure that everything is functioning correctly. This includes verifying the power systems, checking for potential issues, and running diagnostics on the entire setup. Once all systems are operational, the turbine is officially commissioned and ready to start producing renewable energy. Some of the challenges of installing floating wind turbines are environmental. Usually, offshore meteorological factors like winds, currents, and waves interfere with installation. Bad weather can cause delays in WTIV's cutting-edge dynamic positioning systems. This can make lifting turbine components extremely dangerous. The reason behind it is that ocean currents can change location, so operators must always monitor forecasts to choose appropriate installation windows and make necessary adjustments. Another challenge is that the components of the turbine are huge. Blades can stretch over 100 meters, and tower sections can weigh hundreds of tons. Preventing safety problems or misalignments depends on the exact handling and placement of systems. That means we need great accuracy in coordinating cranes and lifting systems with the DP system of the vessel. Now let's look at some of the contributions of WTIV. First, Hywind Scotland. The first floating offshore wind farm ever. It consists of 5 floating turbines, each standing 78 meters tall with blades reaching 115 meters. The credit for the installation of these turbines goes to, any guesses? Yeah, the Floating Wind Turbine Installation Vessels, or WTIVs, that we've been talking about. The success of the Hywind Scotland project validated the viability of floating wind turbines. It showed that these turbines could be deployed in areas previously inaccessible. The project has been a major milestone, and it has proven that floating wind farms can produce sustainable energy even in challenging offshore environments. Next, we have Windfloat Atlantic. It's located off the coast of Portugal. It has 3 turbines each with an 8.4 MW capacity. It was also the first to be installed using a semi-submersible floating platform. WTIVs were used to transport and position the turbines onto these floating platforms, so the success of Windfloat Atlantic is another proof of the potential of floating wind farms. And finally, let's look at the significance of these projects. Both of these pioneering projects tell us how floating wind turbines can significantly contribute to the renewable energy sector. These installations pave the way for scaling up floating wind farms globally. It is showing the potential to power homes and industries across the world with clean, sustainable energy. So let's look at the future. There are exciting developments in the future of WTIVs that will improve offshore wind turbine installation capacities even more. One major field of growth is energy-efficient cranes. This will include lowering power usage during turbine installation and increasing operational efficiency. Also, improved dynamic positioning systems will be even more accurate. They will be reducing the impact of wind and sea conditions on ship positioning. With this, automation systems will become more and more incorporated into WTIVs. This will enable more autonomous operations and lower the need for human assistance. Rising demand for offshore wind energy will call for bigger and more sophisticated WTIVs. Access to more offshore regions would make it possible to set up even bigger wind farms. This will be increasing renewable energy output. Offshore wind farms will become an even more important component of the world's energy mix as technology advances. The worldwide shift to renewable energy will depend on the development of installation capacity for floating wind turbines, especially those with little shallow water but great deep water possibilities. WTIVs will be quite important for nations developing their offshore wind resources. By tapping enormous, formerly unexplored energy resources, this technology will be vital in helping to achieve worldwide renewable energy targets and fight climate change.